Okay, so in this key, you want to evaluate each of these piecewise functions. And so remember these what the graphs of these piecewise functions look like. They're actually pieces of functions. Um, Now, this is section 2.2, part 6. All right, so basically, if you look at this function f of x, it's made up of two parts. And so f of x is going to equal 3x minus 4 for this domain. So the domain that you're going to use this part of function f of x with will be if x is less than 3. And then if x is greater than or equal to 3, you're going to use this part of f of x. Okay, so if you look at the first one, it says you want to find f of 0. All right, so remember, this is 1a. So remember, f of 0 means what's the y value? Remember, f of x is y. What's the y value when x is 0? All right, so you got to make sure you're using the right one, though. You can't use both of them, okay, because then it would no longer be a function. Because remember, definition of function is for each x coordinate, there can only be one y coordinate. All right, so if you did both of them, there'll be two different y coordinates. If x is 0, you'd have -4 here, and you'd have 1 here. All right, so you got to make sure you're using the correct one. So you're told x is 0. So look at this right here. Which of these is x included in? For example, is 0 greater than or equal to 3 or 0 less than 3? 0 is less than 3, right? So you're going to use this one. So we're going to use f of x is going to equal 3x minus 4 since x is 0. Okay? And so f of 0 then will equal 3 times 0 minus 4, and 0 minus 4 is a -4. So that goes here. All right, so that's the y value. If x is 0, here's my y value. All right, you do the same thing with f of 3. So b, you want to find f of 3. So again, you got to make sure you're using the right one. You can't use both. So this time x is 3. So you ask yourself, is 3 less than 3 or is 3 greater than or equal to 3? Well, 3 is greater than or equal to 3, so 3 is in this part of the domain. And so you're going to use this part of the function. So you're going to use f of x is equal to 7x plus 1. And so wherever you see the variable x, you're going to substitute 3. So f of 3 then would be 7 times 3 plus 1. So that's 21 plus 1, which is 22. So f of 3 is 22. And then f of 5, c, f of 5. So again, I got to make sure I'm using the right one. So this time x is 5. So you're going to ask yourself, is 5 less than 3 or is 5 greater than or equal to 3? Well, 5 is greater than or equal to 3, so you're going to use this one. So I'm going to use f of x is going to equal 7x plus 1. So f of 5 then will be 7 times 5 plus 1. So that's 35 plus 1, which is 36. All right, and then, all right, so that was number 1. Okay, number 2. So again, number 2, same idea. So you have this function, this piecewise function, g of x. So g of x is equal to x minus 1 if your domain is greater than or equal to 0. And g of x is the opposite of x if the values in the domain are less than or equal to 0. Okay? All right, so 2a, you want to find g of 0. So again, you got to make sure you use the right one. So I'm going to go ahead and do this here. So you got to make sure you use the right one. So g of 0. So is 0 greater than 0 or is 0 less than or equal to 0? It's this one because it's equal to, right? All right, so we're going to use g of x is going to equal negative x, or the opposite of x. That's how another way you can read this, the opposite of x. So therefore g of 0 then will equal the opposite of 0, which is 0. So there's your answer. G of 0 is 0. All right. Part B. Okay, so in part B, you want to find g of -2. So again, you gotta look to see which one you're going to need. So x is -2. So you ask yourself, is -2 greater than 0 or is -2 less than or equal to 0? Well, obviously less than or equal to 0, right? Because it's negative. So you can use this one. Okay, so remember though, you're going to say this. All right, so first of all, we're going to use g of x equals the opposite of x, right? So g of -2 then will be the opposite of x, and what's x? -2. Well, what's the opposite of a negative 2? Well, the opposite of a negative 2 is a positive 2. So that goes here. So g of negative 2 is a positive 2. And then C, you want to find g of 4. So again, we got to make sure we're using the right one, right? So g of 4. So is 4 greater than 0 or is 4 less than or equal to 0? Well, 4 is greater than 0, so I'm going to use this one. So I'm going to use g of x is going to equal x minus 1. So in place of x, I'm going to substitute 4. So I get 4 minus 1, which is 3. So g of 4 is 3. So that goes here. Okay, now this one's a little bit different in it, because in all the problems you look at, you had an inequality such as less than equal to, greater than equal to. Here we have the symbol not equal to, and then the symbol equal to. So you got to be a little bit careful there. So let's talk about what that means. So notice, let's look at this one. So f of x is going to equal x plus 5 if x equals 2. So if x is 2, if you're told x is 2, then you're going to use this one. If you're told x is something other than 2, you're going to use this one. That's what that means. This right here means x other than 2, if that makes any sense. Other than 2. Okay? So if x is 2, I use this one. If x is something other than 2, like 3, 2.7, negative 6, negative 5.5, I use this one. So when's the only time you're ever going to use this one? Only one time, and when is it? When x is 2. Everything else, you're going to use this. Every other value in the domain, you're going to use this. Okay? All right. Now, also, I want you to remember this. See, the reason why we can't use 2 here, and we talked about this in the previous course and also in this course, is because 2 makes the denominator 0, right? And you can't divide by 0. So if x were 2, if you put 2 here, that would be undefined. Okay, now let's look at 3a. 3a, you want to find f of negative 2. All right, so ask yourself this. First of all, am I going to use this one? No, I'm not going to use this one because I use this only if x is 2. Well, x is negative 2, so therefore I must use this one. All right, now be careful when you do that. So we're going to use f of x equal x squared minus 4 divided by x minus 2. So I'm going to use this rational function. And so wherever we see the variable x, I'm going to substitute negative 2. Now, we've talked about this before. It may be a good idea in some situations to put a negative 2 in parentheses. For example, if I want to find negative 2, f of negative 2, I'm going to say in the numerator, negative 2 in parentheses squared. Because if you don't put parentheses there, negative 2 squared without parentheses is a negative 4. And this is actually a positive 4. So 4 minus 4 divided by negative 2 minus 2. Negative 2 squared is 4. 4 minus 4 over a negative 2 and a negative 2 is a negative 4, right? So that's 0 divided by negative 4, which is 0. So f of negative 2 is 0. All right, let's go to 6. F of 6, part B, f of 6. All right, so again, you're going to ask yourself, which one will I use? Am I going to use the top function for f or the bottom function? Well, remember, x is 6. I only use this if x is 2, so then, therefore, I got to use this one, right? All right, so I'm going to use the top one again. So use f of x equal x squared minus 4 divided by x minus 2. So f of 6, then, will equal 6 squared minus 4 divided by 6 minus 2. 6 squared is 36, so that's 36 minus 4 divided by 6 minus 2 is 4. 36 minus 4 is 32, and 32 divided by 4 is 8. So f of 6 is 8. So that's going to go here. All right, so when x is 6, my y value is 8. And you're going to use those ideas when you graph those. All right, so f of 2, C, f of 2. All right, now this time x is 2, right? So which one will you use? Will you use this one or this one? The top and the bottom? Well, the bottom, because that's where you're told x is 2. You're going to use this if x is 2. Well, x is 2 here, right? So you're going to use this one. So you're going to use f of x equal x plus 5. And so therefore f of 2 then will be 2 plus 5, which is 7. So f of 2 is 7. Okay? All right. And then finally, number 4. Okay, so again, you're told that the function h of x is x squared if the value of my domain is less than or equal to 1, and it's going to be negative 2 if x is greater than 1, right? Okay. Now remember, and we talked about this before. See, this says y equals negative 2. Well, remember, this means, see, there's no variable there, right? So that means that this y value will always equal negative 2 if x is greater than 1. All right? Okay. So part A, you want to find h of 0. All right, so we got to figure out, first of all, which one do I use? H of 0. Is 0 less than or equal to 1, or is 0 greater than 1? Well, 0 is less than or equal to 1, right? So I'm going to use this one, x squared. So I'm going to use h of x equal x squared. So therefore, h of 0 then will be 0 squared, which is 0. So that goes here, 0. Part B, you want to find h of negative 5, right? Okay, so again, we have to determine which one to use. So remember, x is negative 5. So is negative 5 less than or equal to 1, or is negative 5 greater than 1? Well, negative 5 is less than or equal to 1, so we're going to use this one. So again, we're going to use h of x equal x squared. So therefore, h of negative 5 will be negative 5 in parentheses squared, which is a positive 25. All right, C, you want to find h of 5. All right, h of 5. All right, now remember, x is 5, right? Okay, so is 5 less than or equal to 1? Nope. But is 5 greater than 1? Yes. Now remember what that means. Okay, so we're going to use this. We're going to use h of x equal negative 2. So that's what we're going to use. Now remember what that means. That means, right here, that means that my y value equals negative 2 no matter what x is. So if x is 5, what's my y value? Negative 2, right? So remember when you graph horizontal lines? That's that idea. So that's negative 2. So in fact, for any value greater than 1, let's say 1.2, 1.765, 1.031, 8.6, any of those values greater than 1, what will the y value always be? The y value will always be just negative 2. All right, now be careful with D. You want to find h of 1, right? Okay, so ask yourself, if x is 1 less than or equal to 1, or is 1 greater than 1? Well, 1 is less than or equal to 1, right? So I'm going to use this one. So I'm going to use h of x equal x squared. So therefore, h of 1 will be 1 squared, which is 1. Now, one more thing I want to mention. All right, just remember, what is h of 1.23? So if x is 1.23, which one do I use? I use this one. So what's h of 1.23? If x is 1.23, what's my y value? Well, my y value is negative 2. What is h of 2.7? Negative 2. What is h of 7? Negative 2, right? Okay, so as long as your x value is greater than 1, your y value is always going to equal negative 2. Okay, just like you saw here. All right, so that's the key to the worksheet dealing with evaluating piecewise functions.